for you. Can everyone hear me? Yeah? Just wondering if I need a microphone. So first we have Lorena. So Lorena has been working on Kedro since she joined QuantumBlack about 11 months ago, and she has a master's in engineering in computer science from University of Bristol. And then Pulkit has a PhD in engineering and was a postdoc here in Oxford, and he has joined QuantumBlack as a data scientist. Before we get started, I just want to remind everyone that after this talk, there's also a networking and drinks reception outside, if you would like to join and stay for that. But yeah, I'll give it to you now. Thank you. Welcome.
Thank you very much, Sana, for a nice introduction. We are representing QuantumBlack here, and as our logo says, beautifully intelligence, beautifully engineered. We build, or at least try to build, beautiful engineering, analytical engineering solutions for our clients. I am Pulkit Sharma, a data scientist at QuantumBlack. Before this, I was a postdoc at the Department of Engineering Science, University of Oxford. There I was building smart healthcare solutions. We were using machine learning and analytics to improve patients' outcomes in the hospitals. And prior to that, I had a PhD in engineering where my main focus was on speech recognition and speech synthesis. As a researcher and at the University of Oxford and as a PhD student, I was not worried much about the kind of data I need for my machine learning models, because the data we were getting was mostly clean. It was clearly segregated into train and test, so we don't have to worry much about the pre-processing part. But after joining QuantumBlack, I realized that a lot of time and a lot of effort has to be given to the pre-processing and post-processing part. So machine learning or analytics become a very small subcomponent of a very big system, and we need to be in harmony and synchronized with everybody to make our solutions work in real time on real data. And today I'm going to talk a bit about the good software engineering practices for data scientists. A brief introduction, who we are, who QuantumBlack is. So QuantumBlack is a McKinsey company, and we specialize in advanced analytics to help our clients to be better or best at what they are. QuantumBlack started in Formula 1 racing, where margins are very, very small. So QuantumBlack helped its client to perform efficiently, to be better and win race in the Formula 1 track. This was the very beginning of QuantumBlack, almost 10 years ago. But then we have worked with McKinsey across different spectrum of industries. We have worked in pharma, in healthcare, airline, supply chain management, sports. Although we are working across different industries, different domains, but our ultimate objective is the same. We are helping our clients to be best at what they are using advanced analytics. So the underlying chain of events has to be similar across different industries, across different domains. And we, in past 10 years, along working with different clients and with the expertise of McKinsey, have learned that in order to deliver best to our clients, we need to follow we need to worry about three things: processes, people, and technology. So there has to be a set of processes which has to be followed consistently during the project. This involves, best practices, or dividing our time proportionally, equally, doing, getting to the solution and then finding what are the flaws in the solution and iterating over and over again. Second is people. So we need interdisciplinary people with interdisciplinary skills who are specialists in one domain, and also people who are generalists. So say, for example, in our team generally comprises of a data scientist whose job is to get the data and use an advanced machine learning model to get some useful out of it. Team will also have data engineers. Data engineers will have data scientists and others in the team to get the raw, messy, real-world data, derive features which can be used efficiently in machine learning models. We do have expert colleagues from McKinsey who with them bring the expertise of a particular domain. We have translators who help the team members to translate the results coming from a machine learning model into more business sense, so that the results can make some sense to the business. In order to do this, we need to either build technology which is the best, and then we need to follow the technology. Since we are talking about advanced analytics here and machine learning here, we need to be consistent with our technology and follow the best practices. Best practices here mean we need to build a code which is production ready. What it means that my code should not break down when I'm actually employing it in a real world on a real data set. It should be thoroughly tested. It should be modular, and the most important thing, it should be easy for anybody else to understand what the code is doing. As I have already mentioned, as a researcher and as a PhD student, I was not much worried about the kind of data I'm getting, because it was always clean, very, very good. I was mostly worried about the model I'm going to use. So today I'm going to talk about the technology's best software engineering practices from a data scientist perspective, especially if I have to build a model which has to work on real data in real time. So the models which we build, they are used on client side regularly on day-to-day basis. So it should not happen that it breaks. So let me just check if I think the charge is not working. I'm sorry, I think it is now. So recently I was working on a project where the client or the organization, they had addresses of various sites stored in different databases. So just to give you a feel of the problem. So there is an address. So suppose there is an address 108 Woodstock Road, Oxford. It is stored in database 1. It is also stored in database 2. It is also stored in database 3. And the client asked us if we can sort of figure out how many matches are there across different databases. We said, okay, it is probably very easy. And then they also want us to give a measure, how accurate our model is, how good the coverage is. But then there is a problem that there is actually no ground truth. And they want us to give a number, how good your model is. And I asked, there is no ground truth. And they replied, yeah, but you are the data scientist. So I was like, okay. No, this is not only one address, but there are also problems. So there were duplicate addresses. And so the example which I have given you earlier, so 108 Woodstock Road, it can be written as Woodstock Road 108, or it can be written as Woodstock Road 108. Instead of Oxford, it's only written OX. And we don't know how many addresses are there, how many unique addresses are there, and how many matches are there. And we were working in a team, and my job as a data scientist was to come up with a model or a metric which can quantify how good our model is, and how good our model in terms of accuracy is, and how good the coverage is. I looked at the data, figured out there are certain characteristics in which the same data is written across different databases. There were multiple characteristics, as I mentioned, but one of them was the data was actually shuffled. So instead of 108 Woodstock Road, in some other instance it may be written that Woodstock Road 108. So then what I propose, so we will create a sample database, and then we'll say randomly shuffle it, change Oxford to OX, Street to ST, put in some typos, and evaluate our model on this fake dummy data set. And then we can say, if our data, the real data, has these sort of variations, this is the estimated accuracy or coverage of our model. So far, conceptually, it was okay. Not so good, but okay. So then I was given this task of implementing this in a dummy environment. So I'm now actually narrowing down into the problem. So one of the subtasks of this problem is to shuffle the words. And I wrote a function, shuffle the words, and this is the function. And I thought this part of this problem is now done. So I imported random input to this function is a sentence. I shuffled the words and then joined them again, and then returned them back and said, my job is done. At least for this part of the function, not for the whole entire pipeline, but for this part of the function. And we will entirely focus on this part of the function for my part of the presentation. It takes sentence as an input, split it into words, shuffle them, reconnect them, and then send it back. I tested it on a sentence, and the sentence here is, Oxford students are perceived as bad at mathematics. I believe so. If you ask somebody from Cambridge, he may not agree with me. And this sentence was given as input to the function, and this is output in white. Shuffled words. So far, good. I use this function, put it into the code base, and send it. Then other people in the team, senior data scientists and data engineers, they were like, you've not tested your code. I was like, what? I have. See, this works. They're like, this is not testing. You have to test it properly. And you have to use something called unit testing in form of PyTest. I said, okay, I learn it, and they sort of, encouraged me to learn it, and I learned it, and then I wrote a test function for this function. So this is the initial test function which I wrote, and this is the sort of syntax for the test function. So the first thing here marks the sentence I'm going to test, and this is the test function. So any function, you find it with test underscore as a test. Takes sentence as an input, pass it to the function which you wrote, give us a new sentence. Now we have to manually think how we are going to test this function. And it is tested using some assert statements. So what assert here means, the length of the two sentences, the original sentence and the sentence with shuffled word should be. I also checked the set, which means the number of characters, in both the sentences should be equal. And I also asserted that both the sentences should not be equal because we are shuffling the words. So if I pass this sentence through this testing function, it will call this function, assert on these statements. If any of these fails, it will give me an error. If it does not fail, say very good, pass. So this was the function tested. This is the sort of output we are going to expect, and we are going to get. There was one test and it passed. Took some time. This was the one test. So I wrote this PyTest. Then I was asked to do some testing, think of some cases where my function should fail, and pass them, and modify then my function to so that it does not fail in real world scenarios. So I gave three inputs again, 3 sentences, and my test failed. Here it is saying this 1 failed, 2 passed. So there were 3 test cases, 2 of them were passed, 1 was failed. And this is the assertion error it is saying is failing. Assert test is not equal to test. So when I had only 1 word, my function is going to return the same word, and my assertion is going to fail because I'm checking this. They should not be equal. If it is only 1 word, they are going to be equal. So what to do? So I have to modify my function so that it can handle these sort of situations. I modified my function. So this part was the old function. I put an if else statement. If the length of the sentence is less than 1, I'll return the same sentence. Otherwise, I'll shuffle the words and return the new sentence as a shuffled sentence. But if I change my function, my test has to be changed accordingly. So this was my test initially. So length and set should be same. But if the length of the sentence is less than or equal to 1, then I will assert that new sentence should be equal to the old sentence. Otherwise, they should not be equal. So this sort of process, initial process, forced me to think of some sort of edge cases where my function will fail in real scenarios and test it more effectively so that it does not fail when we employ it in a real-time project. I gave some more inputs to it. So this input, after one word is passed, I gave 2 words to check it with the same test, and it failed. Now ideally it should not fail, but it failed. Then I ran it again and it passed. I ran it a few times and sometimes it was failing, sometimes it was passing. Then I realized that my function actually, there is the function, right? So if there are only 2 words, there is a 50% chance that that same sentence will be returned. Because shuffling with 2 words only will give me, there's only 2 combinations. So it may fail again. So that was the reason why this was failing here when there were only 2 words, Oxford, Cambridge. Then what to do? I could have called these 2 statements again, but after shuffling the words, I manually checked there if the new sentence is equal to the old sentence or the shuffled sentence is equal to the non-shuffled sentence, I'll call my function again so that I make sure that it shuffles, especially in case of 2, if there are only 2 words. After changing this function, I tested again and it passed. So this is the test. So far it was good. I pushed my changes and it was working fine until I got a message from my colleague that your function has failed again. I was like, why? I have tested it. It should not fail, but it failed. So I realized that the data was coming from a real source and there were a lot of empty values in the data frame. So there were a lot of nuns, or the data frame was empty, and that was the reason my function was failing. So I discussed it with other people in the team, and they told me that if your function, if the input is none, or if the data frame is empty, you should return an empty or none field. I said okay. So I put another condition, none, in my testing. It failed because it could not split it on none when the data the entry is none or null. So then I had to write another if statement at the very beginning of the function, that if the sentence is none, return the none, because that's what we discussed we want, and the rest of the function will go into else statement. And if I test it now, it will pass. That's what the testing operator is saying. All the 5 tests pass. There are 5 tests here. Okay, but in this case, this was fine, but this made me realize that this probably is not a good idea to manually put sentences here, because as a person, I am limited with my bias and limited with the understanding of edge cases I can think of. So it turned out that Python has a very nice function which can help you in these sort of edge cases, very nice testing functionality, and which is called hypothesis. So instead of manually specifying the number of edge cases you can think of, you can specify what should be the input to this function, and Python will give a number of edge cases on its own, and then test the whole function. So in my case, I have to do a bunch of pip install hypothesis and some import statements. And from hypothesis, I imported given, and given can give me text. I was testing my function on text. So instead of manually thinking of what the edge cases of that text could be, I can let the function figure out how many text examples there can be. I can similarly do the same thing for integers, floats. And the nice thing about this functionality is that you're not only limited with the text which this hypothesis can think of, but you can manually give some examples which you think are edge cases. So you can give text as input to this function, or an example text as an input to this function which you think is an edge case. I use this same assert statements in my PyTest, gave it to my function and tested it. Any guesses you think what would have happened with this case? Okay, let me tell you. Actually, this my function failed with this test case, because text will test it on a lot of edge cases. And one of the edge cases where my function could fail is if we have, say, 2 words and both the words are same, or if we have 4 words if all the words are same, then this function is going to fail, because I am saying here when the new shuffled word is equal to the old new shuffled sentence is equal to the old sentence, it will go in recursion. And if all the words are same, it will never come out of recursion, and the recursion length will hit and it will fail. I discussed the same thing with other colleagues and senior people in my team, and they said, you do not have to worry about those cases because they are not going to be there in our data. So the point I'm going to raise here is testing is good, it's very good, we have to do it, and I did not realize that testing is so important when I was a researcher, where I don't have to worry about the data, but with the real data, I have to worry about testing, and I need to worry about the testing, because otherwise my code will break in real world scenarios. But at the same time, we have to make sure we are not going too much into the testing. We know what our edge cases are, and do not overthink or do not overdo the testing. So the final output, what we started was with this sort of function, small function, which I thought will do the job, but it unfortunately did not. So we had to modify it to get this sort of function. And one more important piece which we have to worry about when we are working on real world projects is this code is going to be used by multiple people, in real time, so it has to be documented properly. You need to use doc strings properly. There is one more problem with this testing actually. I did not explicitly force it to be a string or an integer, the data type. And that's primarily because I just specified that this is input is a string, output is a string, and the pipeline, the data pipeline before this is making sure that input to this function is always string. Otherwise, if we have to test that, we can raise some more assertions, and we may write this sort of test function where we are asserting if input is an integer, it should give an assertion error, and accordingly the input function has to be changed. But that was not the case with us, so we stopped at this sort of junction. So we have to test our code. We have to test it properly, but we don't have to overdo it. Do it in a reasonable manner. So this is the very small subpart of writing production-ready code in pipelines. And thank you very much. That was it from my side. Now my colleague Lorena will talk to you more about production-ready and production-ready pipelines. Thank you very much.
This doesn't work and people hear me if I'm really obnoxiously loud. Yeah. Okay. Okay, I'm just gonna shout if people can hear me. Yeah? Okay. So. Okay. So hello. I am here to talk about Kedro. I'm one of the core developers there. Kedro is a tool that is built by software engineers, but for data scientists and data engineers to use. So who am I and why am I talking here to you today? As I said, I'm one of the core developers on Kedro. I come from a computer science background. I worked as a software engineer before for an investment bank, before moving to QB almost a year ago. And I've been working on Kedro ever since. So the format of this presentation, I'm going to try to give you some context of, like the industry context of where Kedro was born. I'm going to give you the Kedro story and what motivated it to come about. I'm going to go into then the advantages that Kedro brings to your workflow. If we have time, I'm going to try to do a live demo because it feels like it's more useful if you actually see what it's actually doing, and maybe some Q&A at the end. If not, when we have food, we can ask questions then. So I'm going to start with a quote. 87% of advanced analytics projects never make it into production. That's a lot. And we dug a bit deeper. So this is a slide that my product manager craftily made. She went ahead and did a Google search on terms like machine learning production or deploying machine learning. And all those results were scraped. Some natural language processing was done, and then we came up with this workflow. So it's obvious that it's really hard. People think about scaling, oh, it's really difficult. Python, what's the explainability, etc. And one of the reasons why that is because people tend to forget the whole ecosystem that they have to engage with, really. The ML code, as you can see, it's a really, really tiny part of the whole thing. You have to think a lot about your data quality, how do you collect that data safely and securely, GDPR and everything. how do you configure everything so that you don't accidentally override something where you don't have permissions to, resource management, and then further on, like, how do you monitor that model to make sure that it's still relevant in time, and how can it be supported by people that don't have any knowledge of its background. Which brings us to the Kedro story. Before I go into it too deep, I just want to make sure that we all use the same terminology. So when I talk about a data pipeline, I mean it's the process of taking some input data from one or many sources, doing something to that data, and then placing it somewhere else. And that doing something to it part can be machine learning. And then when I talk about production-ready code, some of you might be thinking, why do I care about this? I'm not deploying anything into production anytime soon. You're wrong. Your research is equivalently important, because the same principles apply there as well. You want to be able to reproduce your experiment results. If you have the same code and the same data, you should have the same results. There's no reason why you couldn't. In the same environment setup and everything. So that's the main point, and then we also want to make sure that it can be easily broken down into components that are small, well-defined, and also people can read your code, and it's easy to maintain after reading. So at QuantumBlack, we noticed time and time again that there were some challenges that we kept coming up against. One of them was effective collaboration. So people come in and out in a project, and then also in general people have different styles. So how do you cater to those differences that end up wasting time anyway? Efficient delivery. So you want to be able to write code that's good enough that you don't want to be forced to refactor everything at the end. Maintainable code, as I keep saying, your code is meant to be written by other people and only incidentally run by a computer. So make sure you need to make sure that your code is readable by others. Data variance, so this is what Phuket has also mentioned. Your data quality can vary. You need to make sure you're protected against that. And then how do you monitor the model performance in production? So Kedro aims to protect you for those first three ones: effective collaboration, efficient delivery, and maintainable code. This is a typical machine learning use case. You have some raw data that you cleanly try to ingest. You then clean and join the data to make it relevant for the feature engineering. Once you have your relevant features, you train and validate your model, and then hopefully if it's good enough and performant enough, then you deploy it. So Kedro is an open source Python library, and it helps you build production-ready code for your data pipelines. It also ensures effective collaboration. It takes some of the thinking away from the little details of conventions and things like that. And then it's also trying to instill good software engineering practices onto people that don't necessarily have that software engineering background. So we like to position ourselves as the bridge between machine learning and software engineering. And being open source means it's easy. You can just do pip install Kedro, and it's as easy as that. You have it on your computer. So some of the things that Kedro brings to the table: we give you a project template. So when you start your Kedro project, you have a folder structure already in place. You don't have to argue about where do we put this code, or where do we put the test code and everything like that. It's that thing he's taking away from you. You have a place to put your configuration in, and so you can define different environments to make sure that you're separating concerns clearly. And I'll I'll go into a bit more details about each of these, so don't worry about it being too abstract at the moment. Data catalog is the place where we define how you load and how you save your data. It can be from CSVs, it can be from Excel, from S3 buckets on Amazon, etc. And then nodes and pipelines are the core building blocks, which I'm going to go into in a bit. They're essentially just Python functions set in the right order. So this is a part of the project template. As you can see, you have configuration. We have a folder for logs. We have integrated logging with the inbuilt Python framework. We have a folder for notebooks. So this is for Jupyter notebooks if you want to do some experimentation first. That's a place where you can try that. Of course, we have a folder for where you keep your Python scripts. We encourage test-driven development. As it was previously mentioned, it's super important, so we have a folder for those as well. And we integrate with PyTest for unit tests. And then documentation, we are using Sphinx for that. Again, an important part because once you hand it over, you want to make sure that people know what your code is doing, or what it's meant to do at least. Yeah. Okay, so configuration. Here you can define how you load and how you save your data. You can also define your parameters, so it's easier if you have it in one place, so you don't have to look through the entire code base. Oh, where do I use this variable, and everything like that. You can also keep credentials safe out of your code base. We still encourage you to use environment variables, but this is a way to kind of emulate a production environment on your machine. And logging as well, you can set up your logging specifications. And so the credentials look something like this. Everything is written in YAML files, so it's easy to read, also from a business user perspective. So you would have something like dictionary like this. This is the type of data, so this is how you define your loading and saving type. As you can see, I'll go into it also in the live demo, but I have this data set called cars. I want to load it it's a CSV, so I want to load it appropriately using pandas. We try to abstract that repetitive code away from you, so you don't have to do read CSV, read CSV, read CSV every time, but you just define your configuration in one place and everything is handled for you. Yeah, and this is just another example integrating with an SQL data set, or SQL or database. So the data catalog has a number of different storages that we are trying to integrate with. I mentioned S3 earlier. We now have support for Google Cloud Platform as well. Some support for Microsoft Azure. We're trying to build up on that. Different inputs that we support. I mentioned CSV and Excel. We have JSON as well, Pickle, Spark, SQL, and many others that are not mentioned here. But it's extensible. It's quite easy for people to build their own custom data connector, as you may also want to call them. It's available as YAML API, as I've just shown you, or you can use it programmatically. You can use the code as well. And also we support data versioning. So if you want to keep track of your data changes per pipeline run, all you have to do is just add one liner, which I might be able to show you, and then it will create separate folders with the relevant timestamp for your data sets. So you can go back and check what the differences are or whatever you want to do after. bit about nodes and pipeline. There's this concept in Python of a pure function, and a pure function is just a function that takes some input, spits some output, and there's no side effect in between, which is very important. So a node is essentially a Kedro wrapper around a pure function. And it looks something like this on the right-hand side. And it tells you what to run, where to take the inputs from. And these are catalog entries, so these are the keys in your YAML file. Where to put the outputs, and any other important metadata that you want to store, like a name for your node or tags. So I said node is essentially just a Python function with an input and an output. We support multiple inputs if you want to do, say, like a table join, but also we support multiple outputs in case you want to do like a split between training data and testing data. And that's just a visualization. And so pipeline is just a collection of those nodes. And there's another concept in computer science called DAG. It's a directed acyclical graph. And it's just a bunch of nodes with their relationships defined. So you define your inputs and outputs for each node, and the pipeline would automatically do dependency resolution, so it would know which ones to run first and which ones to run after and everything like that. So you don't have to hold the structure of the graph in your head. We do it for you. And then we also give you some cool visualization tool, which is in the process now of redesigning, but this is what it looks like at the moment. Our Klein teams have used this a lot as a communication tool. It makes it easy for non-technical people to understand what's going on in the data pipeline, and it's fairly interactive, so it's a nice experience. It gives you an overview of the whole structure, and it's also all generated from code, so you know it's like live documentation. You don't have to go ahead and tweak every time you change something. So we have a light and a dark theme, which is Apple. So these are our resources. We are on GitHub. As I said, we're open source. If you have any issues with it, please feel free to raise an issue there. We have documentation on Read the Docs. We also have a nice tutorial there that can get you started. I think it's meant to take 1.5 hours, something like that. And we are also trying to build our community on Stack Overflow. If you have your question with Kedro, we'll be checking those regularly so we can try and answer your questions. So I managed to still have time for a live demo, but if you have any questions so far, please shoot, and I'll try to get my thing working. Some questions so far? Yes.
Yeah, I was wondering, is it becoming more commonplace, or is it part of the objectives of QuantumBlack to be producing open source products? Is that something that we can be expecting more of?
I want to believe yes. I think we're seeing definitely the benefits of going open source. We've open sourced another Python library this month. So yeah, I think we're getting traction on that front. So hopefully you'll be seeing more cool products from us. Good question. Can everyone see my screen, or should I? Yeah, can people read at the back? Cool. So I've already gone ahead and pip installed Kedro and Kedro Viz. if you remember the visualization, sorry, I should have mentioned that. It's an additional plugin that you also have to install. It doesn't come with Kedro, but it's easy enough. You just run another command. Okay, so this is where I am now. So I can do Kedro to create my project. And you see it prompts me to enter a project name. Then a repository name. If you keep pressing enter, you will just use the same default Python package name, and then we can generate an example pipeline for you, so you can get started to see what it looks like. And I'm gonna say yes. Cool. Let me go in there. So this is what I have here. As you can see, the notebooks folder, the logs, references are fairly optional if you want to include references to any papers that you're using for your models. Let's go into data. So these are the folders that we recommend. This is according to a data engineering convention. So you go from raw data to an intermediate layer to a primary layer, and then you have your features, model input, and so on and so on. And then maybe at the end, maybe you want to do some reporting for business users or for any other stakeholder. Configuration. So we have a base environment and a local environment. The way Kedro works is, so you can specify which environment you want to run in, and it will load that environment on top of base. So if there's some kind of configuration that is common to every environment, you specify it in here, and then any extra quirks that you have to specify go into your specific environment. Okay, I'll show you in base. Yeah, so I have a catalog, configuration, parameters, credentials, logging. I'll show you the parameters. So it just looks like this. I only have 3 parameters. Actually, let me look at the catalog. What can I see anything? Anyway, I only have one input data set, which is a CSV data set, and it lives in raw. And we give you some comments as an example of this is how you would, this is the type of syntax that you would use for the different types. Okay, let me go back here and show you the Python structure. Cool, so it's a very simple pipeline. I get the raw data, I split it into train and test. Into train X and train Y. I train the model, and then I do some predictions, and then I do some reporting of the accuracy. I want to hide or show the parameters if that's useful. It will tell you exactly which parameters you're using as well. Okay, let's, what else can I show you? Kedro help. So this is giving you a feel of how many different commands you can run. So if you have the global commands, which is I showed you Kedro new. If you have the documentation of the Kedro API, you can use docs. But the more interesting ones here, Kedro run. Kedro test will run all your unit tests. Linting, if you already have these installed, it will do the aesthetics basically for you. You can build a documentation, package it as a Python package if you want to ship it somewhere else. Yeah, so these are the logs that are spit out by the run. I'm loading, as you can see, I'm loading this data set and some parameters. And then I'm running this node. And then training, and you get checkpoints of how far along you are. So 1 of 4 tasks for one. Kedro test. Yeah. It will also give you like a coverage report. As you can see, by default, our coverage is not very good in the example project, but that's on you to fix. So it tries to encourage you to still do better than 48%. What else? That's the requirements that we encourage you to have to start with. So as you can see, PyTest, we're keen. Jupyter for your notebooks. Jupyter Lab. Okay. So we have a couple of pipelines. A data engineering and a data science pipeline. So this is the only node that I have in my data engineering pipeline. It's just in the data. And if I open the actual pipeline, yeah, if you remember from my slides, it's just a collection of nodes, so this is how you would typically specify it. Yeah. And I've got 1 minute to go, so if anyone else wants to see anything else, shout. Now's your chance. I'm assuming you'll want to do it on your own time then. So. Thank you. Thank you for your attention.
Don't forget there's a drinks and networking reception right after this if you want to ask questions like more one-on-one and yeah.
And sorry guys, one more plug from us. So thank you Lorena and Bulkit for coming in to speak. Oxy are actually running a trip to QuantumBlack's offices in London next week. And we'll be visiting some other offices for some other AI related firms. So we're going to visit Founders Factory, AIG and also MedoPad. So if you're interested in that, the link is on our Facebook page and apply before, I think actually the deadline's tomorrow. So hope to see lots of you applying for that.
When is it exactly? When next week?
Yeah, Thursday next week, a week today.